You're welcome to our today's class. Today we'll take a look at physics. Physics. And we'll see what you can do on the topic motion. See what you can do on the topic motion. As usual, we review past questions and take it off from there. Just as we did yesterday in chemistry, we'll solve some questions in physics in motion. Our reference book for today is Prep 50 Physics. Prep 50 is UTME past questions and New School Physics by Anya Kohan. So, Okay, let's look at the question. The question says an Air Force jet flying with a speed of 335 meters per second went past an anti-aircraft gun. How far is the aircraft 5 seconds later when the gun was fired? A. 838 meters. B. 3,350 meters. C. 670 meters. D. 1,675 meters. JAM 1978 question 3. I give you 5 minutes. Try this question. Try solving. Let's see what you can get. 5 minutes is too much. I give you 2 minutes. Try. What's the answer? What was the score in Mass Wayek? Eh? Pass. 6-6. This is income. Oh yeah. What's the answer? Solve it. What is the relationship between distance and speed? Mathematically, huh? Speed is what mathematically? Time. And so, what do you think? Take it. You do you know the issue you have. You believe that you don't know mathematics. You believe you have told yourself I don't know it. Try to reason out this question. You can solve it. Look at it critically. Reason it out. You can solve it. You have told yourself I don't know it. You switch off. As a scientist, you reason. If you see a question, try to imagine it. Try to find out. Try to reason it out. The answer will come out. The solution will come out. But if you don't want to, put your mind at work, you can't solve problems. I'm asking you now, what is speed? You take that speed is the distance over time. So why can't you solve this question? It's because you have told yourself, once you look at it, it sounded somehow. Yeah, I don't know it, you switch off. It's wrong. It's a wrong attitude to learning. You see a question, try to take it out. Try to imagine it, try to reason it. And you see you start solving it. So solve this question. waste our time. Let me solve it. Look up. All the answer. Huh? D. How did you get it? Uh, is it what? It's what? Speed is what? Okay, correct. But there's something I want to explain here. You got it. The answer is D. You got it. But there's something I want you to understand about the question so that if they twist this type of question, anyhow, you can solve it. Now look up. You also say that an Air Force jet flying with a speed of 335 meters per second went past an aircraft. So the aircraft is going like this, let's assume, with a particular speed, with a speed of what? 335 meters per second. This is the aircraft going like this. Air Force jet flying with a speed went past an aircraft gun. The aircraft gun is somewhere here. It passes it and continues moving with this speed. We are told we don't ask how far is the aircraft. How far is the aircraft? 5 seconds later, when the anti-aircraft good. How far is the aircraft? How far is this one now? 5 seconds later, when the gun from this was fired. So 5 seconds later, 5 seconds after passing this, remember it's still moving with this speed, right? So 5 seconds after passing this anti-aircraft gun, 5 seconds after this was passed this, what distance has it covered? Would it have covered? It's simple. So if you know that speed is this, sorry, distance, speed is what? Distance over what? Time. Then how far is distance is velocity, speed times time. Now, how far it would have passed from here to here after 5 seconds is divide the speed by the time multiply the speed by the time in question. See it here. The answer is what? 3 what? 5 meters per second times what? 5 seconds. Second will be what? Count seconds. 5 times 3 times 5 is 165. No, 1,700 watts. 1,675 meters. Is it clear? You got the answer, but I just try to explain something. That it passed is fired after 5 seconds. How many passed that gun? The gun was fired. So and it didn't change its velocity, its speed did not change. The Air Force jet is moving with the same speed. So, but after 5 seconds, what distance will it have covered? It's simple. You use the formula and get the what answer. Is it clear? Any question? Any question? Okay, let me look for another question. Question says a palm fruit dropped to the ground from the top of a tree 45 meters tall. How long does it take to reach the ground? Acceleration due to gravity is 10 meters per second squared. Then the option A 9 seconds, option B 4.5 seconds, option C 6 seconds, option D 3 seconds. JAM 1978 question 4. Can you solve the question? Huh? No, it's not true. I give 1 minute. Try. Think about it. I give you 1 minute. Reason it out. You can solve it. 1 minute. Oh, I don't understand this now at all. All right, so let's continue, please. I've told you what these things mean, okay? Final velocity, initial velocity, acceleration, not acceleration, time, final velocity, initial velocity, acceleration, distance, distance, initial velocity, acceleration, time, total distance, average speed, final plus initial. Divided by two is average speed times time. Is it clear? Now, this is motion in a straight line, linear motion. But for motion under gravity, for an object thrown upward and it fall, and one falling from up down, is that these ones are motion under gravity. You consider the direction of the object with respect to the gravity. You know if I fall off from here down, if I fall from here down, from here now down, I am in the same direction with gravity. I am in working with the gravity. Hope you know, because gravity pulls something down, right? So if I fall or throw something from here, it's in line with the what? Gravity. But if I throw something up, that thing is working against the what? Gravity. That gravitational force will stop it. It will get to a point and get tired and start falling. Now, when I throw something from down up, I impacted an energy there. You see rockets, they impact energy in that rocket before they fire it to go up. The why it goes so high because of the energy packed in it. Now, what I threw, if I throw something from here up, that thing is moving. If the initial velocity is at maximum, low is maximum. Initial velocity is what? Maximum. If you keep going low, as it's going up, working against gravity, the velocity will be going down, going down, going down, going down. It will be retarded until velocity becomes what? Zero. You cannot go up again. It will start doing what? Falling. It becomes the velocity has become zero. So final velocity is what? Zero. It will start falling down because it's working against what? Gravity. Gravity is fighting it. But if I throw something boom down, it's working in line with gravity. So if something is falling, both the motion under gravity and linear motion, they use this formula. But the difference is that where you see A, it will change to what? G. But be careful about the sign. If that thing is falling from up, G is positive because it's in line with gravity. But if that is going up, G is what? Negative. Am I committing? Now here, this distance will turn to height. A to do what? Turns to what? Height. But velocity and reverse will not change. Time will not do what? Change. Now let us, with this I'll explain now. If you look at this question, before you turn this linear equation to equation for motion under gravity, tell me from the question, tell me the formula that will suit to solve this question. How? Look at the question you are giving now. Are you reading tomorrow? Look at the question. Try to understand the question before you can choose a formula. Look at the parameters given and the parameters you are looking for before you can decide. Well, what do you say is 7-1? What again? Is there velocity there? Which one? Why do you say the total one? Good. So we will use what? We use what? This one, the third one. Hope you have put down this equation. Please do. So we can solve this question. Okay. Okay. We agree that we use what? S is equal to what? Ut plus what? Remember, this is for linear. So let's look at motion under gravity. This will change to what? Height, h. Initial velocity is what? From what I explained here, what will happen to the initial velocity? You are dropping it from height down. If it's falling from height, initial velocity is what? 0. Good. Whereas it's working in the same line with gravity so it is accelerating. So the velocity is increasing. But the initial one is what? 0. Because it fell off. You say it dropped. Okay? Now, because initial velocity is 0, here it becomes what? Huh? 0 times t is what? 0 times t is t. Hey, here it becomes what? 0. Here it becomes what? 0. What happens to G? Will G be positive or negative? Positive. So here this is 0 plus half G t squared. Is it clear now? So the height is equal to what? Half G t squared. Is it clear? But we are looking for time. Right? So let's make t the subject of the formula. So t is equal to, if you divide both sides, remember this is sitting as say 2. Hope you know that. If you divide both sides, you have what? 2 whole over what? Over G. So if you make t the square of the formula, it becomes what? We are aiming for t now, not t squared. So make t the square of the formula here. Yes. You do what? You square it right both sides. So what will be the answer now? What will be the answer now? Can't you hear me? Is what? Okay. Make t the sort of formula here. Is what? Now tell me. Can I see the board? Okay. Make t the sort of formula here. What will now be t? That's my question. Is t squared not t? Is this t or t squared? So make t sort of formula. So what will it be now? That's the question. The question I been asking you here since. So T now becomes what? T will become what here? Look at this situation. T is now what? Is equal to what? Forget answer here. Were you not the one that said that you find square root of both sides? So if come out, sorry, come out here, come out fast, come out. I don't, come on, let me see what I'm saying. Oh yeah, take. This is what you should know by now. That's why I'm acting like this. So, oh yeah, oh yeah. What you know, T is now equal to what? Write it, let me see. Write it, let me see. Mm-hmm. What are you doing? Leave this side. We are still working with the equation, not solve the question. T is what? Write it now. Go and sit down. Go and sit down. I want you to learn how to express yourself. Soon you enter the world, learn how to express yourself. If you ask questions, express yourself. It's very important. Learn that thing. You are lacking in that area. Express yourself well. You did hear me? It's very important. What you know is in your mind. If you don't express it, nobody will know that you know it. But if you ask questions, learn how to express yourself. Communicate well. You know it, but how to express it was the issue. And now that I will give you hot, so you can bring it out. It's very important to do that, okay? Good. This is what T is now. Having arrived at this point now, we can now solve the question, right? Hope you know that you can still substitute yourself and solve the question. Hope you know. You can at this point, you may not necessarily go to this level. You can at this point put the values of this number and find the answer. Hope you know. But there are some questions they will leave it in this form in JAM. There are some JAM past questions you see the answer in this form. They will not give you any value. That's why I want you to find it like this first before you substitute. Are you clear now? You can, when you go to this place, H is 45 meter, G is 10, T is unknown, 2, 10 divided by 2 is 5, 5 divided 45 is 9, square root of 9 is what? 3. The answer is what? D. But there are some questions that want you to believe the answers in this form. So I want to explain it to you. That's why I want to solve without substituting. But now that we are here now, we can now substitute, okay? So T is now equal to what? Square root of what? 2 times height is what? 45, right? Meter. Over what? Over what? 10 meter per second square, right? Of course, 2 divided 10 is what? 5. Of course, meter will cancel meter, hope you know. Then, 5 divided by 5 is what? 9. 9 meter. Square 9 second square. Hope you know this second square, this is per second square. It will come up. So we are with 9 second square. The answer will be like this, 9 second square. But we want to solve it. This is what? 9 square root of 9 is what? 3. Square root of second square is what? Second. So the answer is what? 3 seconds. Is it clear? Is it clear? Good. The answer is what? 3 seconds. question. This question is technical. See how they are shouting. Because it says the particles x and y starting from rest cover the same distance. The acceleration of x is twice that of y. The ratio of the time taken by x to that taken by y is a half, b 2, c 1 over root 2, d root 2. Jump question 1981, question 35. I give you 1 minute to think and tell you what you can do to the question. One minute. Yeah, 1 minute has elapsed. What do you think? Huh? Hey, how do we get A? How do we get A? Huh? Can I come and solve it? All right, let's solve it. Look at the parameters in that question. Which equation of motion do you think we can use? Look at what was given and what you are looking for. What equation of motion do you think we can use based on what is in the question? Huh? If you look at the question now, you find out that there is distance, there is acceleration, there is time, and they started from where? Rest. So they have initial velocity, which is what? 0. So we use this is equal to is it clear? But as we are but there's something here. We are comparing motion of two particles, not one now. So if two of them started from rest, so for two of them, initial velocity is what? 0. So everything here is what? 0. So S is equal to what? For two of us, we are going to find the time. The time before we can compare solve the ratio of their time. we should find their individual time, two of us. So let's make time the subject of the formula. T square is equal to what? This time this is 2s, right? Over what? A, right? T square is equal to 2s, that means T is equal to what? Square root of what? This is T, right? Good. Now, we now let's determine Ts and Ty. Ts time taken by particle x, okay? While Ty is time taken by particle what? Y. Are you following? So we split this into two times now, right? Tx is what? Time taken by x. Time taken by s is equal to what? 2s here becomes what? Distance by color by s. 2 of us over acceleration of what? X. 2 of us. While tx, ty is now equal to what? 2s y. 2 of us over what? ay. Is it clear now? Good. Good. Remember, we are comparing their ratio. So, ratio of this to this, ratio of this to this, is set as saying what? This over this. Two of us, set as saying root 2s x over what? Over what? Root what? 2s y over what? Y. Remember the law of indices in mathematics. If you have this and this, it becomes what? Two of us, it covers both of them, right? 2x x over x over what? 2 what? sy over what? ay. Is it clear? Is it confusing? Good. Not only know what you mean yes, so if it's confusing, let me know so I will go back. Let me clean the question so we can solve up to this place. So, I clean the question. There's something I am so to pick for the question. For the question, we are told what? No, there's continue.
S and Y expressions of x covers the same distance. The acceleration of x is y.
Good. That's what I wanted. The first thing is that remember that acceleration of x is equal to what? 2 times what? Is it clear? Remember this, right? The acceleration of s is 2 times acceleration of y. Continue.
The ratio of the time taken by x that's taken by y is
Ratio of what?
the time taken by x.
Start from the beginning. What do you say about their distance?
Two particles, x and y, starting from rest, covers the same distance.
Come on. Are you there now? The distance of x is equal to what? Distance of y. Is it clear? While acceleration of s is to y. So we put all this in here and get our answer. Is it clear? So ratio of what? Tx over what? Ty is now equal to, let's substitute. If you look at this place, we are told that ax is to y's ay. So everywhere we see ax, we put 2ay. Is it clear? So everywhere we see ax, we put 2ay. There's ax here, right? So we put 2ay. 2 what? ay. All over. Is it another s here? All over what? 2sy over what? AY. Is it clear? Look at it now. What is confusing here? Everything here is here. But we have AX here. We know that AX is equal to 2AY. So anywhere you see AX, we put 2AY.
Yes, why?
2SY.
2SY.
I'll put it now.
Right.
What is that?
2SY, the one.
Where? Which one? This one.
One.
What happened to it?
2SY by AY.
See it here now. Hope you know how we got this. Look at it here now. It's not the same thing. Are you so confused? Are you sure? So my target is to replace this AX by this, because AX is equal to what? 2AY. Is it clear? Now, but this one on top, there's something here. Remember that SX is equal to what? SY. So anyway you see SX, we put what? SY. So we put it here. We now have what? Two words. Is it clear? Good. Remember what I told, what we discussed about. Hope you know that this is something I say. How do you put this thing down? Put it down now. I don't want to clean our option. Okay, let me just look up. Hope you know that this is here that is something I say 2SY over what? 2AY divided by what? 2SY over what? AY. Do you agree with me? Are you sure? Are you sure? Good. You may not just come and let's. If you want to work on this, what I will do is if it turns to multiplication, what happens to this fraction here? You invert, right? So this therefore tx over ty is now equal to what? Everything is what? 2sy over what? Times what? Over what? Is it clear now? This will do what? Cancel this. AY will do what? Cancel AY. Do you agree with me? You are left with what? With what? 2. This is over 2 now. Is root 1 over 2. Is it not? Is it clear? Are you sure? Are you sure it's clear? Okay. So, root 1 over 2, if we split it, we can have something that is root 1 over what? Root 2. 3 of us. Root 1 is 1. 1 over what? Root what? 2. The answer is what? It's what? How is it D? Look at the answer here now. What are you saying? But why did you mention D? This root belongs to 2 of them, 1 and 2. Which one is in option? This is root 2. Wait, let me confirm, sorry. It's root 2, sorry. It's root 2. Did you write it with 1 over 2? So then why is it that it's the option? Is root 2, sorry. You know, I read something here before, so I got reading it properly before that thing is with two, not. So if you, this root belongs to two of them. If you split it, root one will go up, root two will be here. Root one is one. So here is now equal to one. This becomes a sum, and here we know one over what? Root two. So the answer is what? Is it confusing? Is it clear? Are you sure? Good. Alright, so put it down. Let's look for another question before our time elapses. Look at this question. The question says, a mango fruit drops from a branch 10 meters above the ground. Just before hitting the ground, its velocity is, they give us acceleration due to gravity to be 10 meters per second squared. A, 10 root 2 meters per second. B, 10 over root 2 meters per second. C, 1000 meters per second. D, 5 root 2 meters per second. JAMB question 1982 question 13. Try this one, it's simple. Try it, it's simple. All you need to do is just to find out the equation of motion you need. Of course, you know that this is motion under what? Gravity. So try it, let's see. I give you 1 minute to 2 minutes to do that. 2 minutes only. Elapsed. What's the answer? 20 what? There's no 20 here. 20 what? It's alright, let me solve it. Don't worry. Remember, the first thing to do is to check the parameters you were given. Then check the equation of motion that contains all those parameters. We are given height. We are given acceleration due to gravity. We are told to find the velocity before it hit the ground, that is the final velocity. We are told that it dropped from a branch, that means it had initial velocity, which is 0. So which equation of motion has initial velocity, final velocity, height or distance? This three. Which one? Which one? Good, correct. Do you now see how to solve the question using equation of motion? Calm down, look at it, try to understand the question. So we have v square is equal to what? U square plus what? 2as. But this is linear motion. We move it to what? Motion under what? Gravity. So here we stay v square. Because we are dropping it from top, u becomes 0. True of us. Here is what? 0. And because it's in line with the gravity, G is positive. True or false? Here is say what? Positive. 2 what? A will turn to what? G. S will turn to what? H. So that means V square is equal to what? 2GH. We are going to find what? V. So we get the square root of both sides, right? Square root of V square is what? V. Square root of this one is what? With what? 2GH. So we now solve. Let us now substitute. V is 2 times, as selected to do the gravity is what? 10, right? 10 meter per second squared times the height is what? 10 meters. Is it clear? Remember your sword. Hope you remember your sword. Square root of 2 times 10 times. There are 2 10s here, right? You bring out 1 10. True or false? True or false? You know that one? Huh? Hey. What's going on? What happened in your school? This is SS1 topic. What's going on? It's SS topic. And you really aware. What's going on? It's okay. Don't worry. Hey, this is so very simple. It's a perfect square, right? 10 times 10. You take one of 10s. Because, okay, let me split it, okay? Should I split it for you? Let me split it. If I split it now, you have something like this. But let me tackle it. Don't worry. Here is what? Let me move the unit to one side so that it will be easy to solve. Is what? Root what? 2 times 10 times 10. Meter times meter is what? Per second what? Square. Is it clear now? Good. Now let me split this thing. Okay, let me split it. If I split it, I'll have something like this. If I split it, I'll have something like this. Root 2 times root 10 times 10 meter square per second square. Is it clear? Root 2 times root 2 is what? Root 2 times 2 is what? Root 4, which is what? 2. So 10 times 10 is what? Which is what? So root 100 is what? That's I say you take one of it. Is it clear now? This is times 10, right? Good. But there is meter square here, so you take one, you square. You take one. True or false? True or false? You take one. There's per second square there, you take one, right? Per second. Is it clear? You bring out this one. Root 2. Is it clear? So you have something like this. Remember you are solve. Root 2 times 10 meter per second. It becomes what? 10 root what? 2 meter per second. Is it clear? What's that sound? Is that bring the options? From your book, what answer? But did you know the question? Okay, come on, let me write the options again. Option A says 10 root 2 meter per seconds. This is 10 over root 2 meter per seconds. This is 1000 meter per second. This is 5 root 2 meter per second. The answer is what? The answer is what? A. Is it clear? Are you sure it's clear? Okay. For today, okay? Please, as you go home, solve as many questions in motion. Okay? You are not that sound. In fact, you don't know motion. Let me say with you. You have solved as many questions. Please. Please study. You don't study. I beg you, please study. It's very important. Alright, thank you very much for today. See you again next time. Okay? Unless you have any question to ask, no question, right? Everything we discussed today is in order, right? Alright. Thank you very much for your attention. See you next time.